Okay, now let us look at about moment of a couple. Before we can look at the moment of a couple, we know moment is just a matter of multiplying to get a moment. We multiply the force and the perpendicular distance from a given point. But now when we are talking of a couple, we have couple of forces. What is a couple of forces? Do we know a couple of forces? Or in a layman's way, who can tell us what a couple is? Do we know couples? Do we know what a couple is? So and so is coupling with so and so, right? Couples. These are two things that are working hand in hand, right? A man and a woman staying together, right? Coming to make a living, working together to make a progress, right? So even in forces, there are forces that act like couples. If one is not there, then the other one will not what? Will not work. That is what we call couple what? Of forces. So couple forces are forces that are actually of equal magnitude, but they act in opposite what? Directions. Right? These are forces of equal magnitude, but they act in different directions. We can have a couple force can be two forces, F1, then there is F what? F2. And the distance between them can be D. That's the distance between them. So we want to know what I call a couple is F1 and F2. They are of equal magnitudes. If F1 is actually 50 newtons, then this F2 is also going to be what? 50 what? Newtons. But they act in opposite what? Directions. So F1 is just equal to F2, but only that they act in opposite what? Direction. The negative is to show that they act in opposite what? Directions. Is that okay? So this is what we call a couple forces. It is applied in our daily life, in our daily living. Couples are applied. Who can tell us? Now that you know what couples are. Yes? When you're riding a bicycle, okay? You have one leg takes, one the other comes, okay? You are creating, you can have a bicycle when you can have your legs, maybe when the bicycle is smoothly moving on the road, you can have your legs rest on the pedals, okay? So that resting, the force that this leg is applying is the same force the other one is applying. And that is why they are balanced, okay? I see that? That's a couple you have created. And for you to keep moving at the same speed, the force that you apply here should be the same force that you apply on the other leg. Okay? That's a couple riding the bicycle on the pedals. What else? When you're turning the bicycle, still, it can be a bicycle, it can be a motorcycle, you're riding, you have two hands. If you're moving like this, maybe you're going to negotiate a corner, then you have to turn, okay? So the force that you take the other side, you use for pushing it this way, must be the same force you take, you bring this one, this other side. Of course, you don't bring it so fast, just something slowly, okay? But that's a couple already. The force is acting that way, it is acting the opposite way. They are two equal, but then they are in opposite directions. Okay? Opening padlocks. Okay? You have a padlock, you have to turn. I think that? Turning it. The key is going that way. Okay? And the padlock opens. Couples that it is applied in opening the taps. If you have the holes not tapped water, and you're opening that, you're applying what? A couple. Okay? Two equal forces but acting in opposite what? Directions. Your arm may apply 20 newtons. The tap has to rotate 20 newtons. I see that? So that is what we call couples. But we want to know the moment of a couple. If I have now these two forces which are of equal magnitude and acting in opposite directions, but I want to get their moment, what do I do? I see that? So that is what we are going to look at right now. Write and say, a couple is a pair of forces. Another application of couples can be in the steering wheels of vehicles, okay? You have that when you are driving. Of course, there are some people who drive recklessly. They want to use one hand. That's not advisable, okay? When you're driving, you use your two hands. One this way, you have that steering wheel, okay? You have it that way, the steering wheel of that. You have that central point. Can have that. So while one arm takes it that way, one arm brings it this way, okay? So you have a couple always being constituted. All the time you are doing that. You're balancing, okay, using that steering wheel. But each time you're balancing, you're moving it, you're applying couples, okay? Equal but opposite in direction. Let us say a couple is a pair of forces of equal magnitude acting in opposite directions. A couple is a pair of forces of equal magnitude acting in opposite directions. A couple is a pair of forces of equal magnitude acting in opposite directions, and whose lines of action do not interact. And whose line of action do not interact. And whose line of action do not interact. A couple is a pair of forces of equal magnitude acting in opposite directions and whose lines of action do not interact. And whose lines of action do not interact. In fact, for the couples, their lines of action do not. The line of action of this one will be acting like that. The line of action of this other one will be acting that way. They cannot meet. They can't interact. Okay? That's what we are talking about. So let's have this drawn. Let's draw this and then we see how we can get the moment. This is F1. This is my F2. Of that. The distance, the line of action of this one will be that. That's its line of action. Be along that. The line of action of this one will be along that. So let's say the distance here is D. Let's have a turning point. We are going to have moment about some other point. Let me say, call this is point A. And let me call up the distance here being X meters from point A, like that. We have the diagram. We have a reference point, point A. We are going to take a moment about point A of each of them. We're going to get a moment of each force about point A. Now, in this case, we know that for this, F1 is equal to what? F2. Only that they are opposite in direction, okay? Yes. Negative means that they are what? They are opposite in direction. Like that. So we are going to take moment. Taking moments about what? Point A. We are going to take moments about point A and we'll see what happens actually. So we are going to take moment of F1 about A. Should be, this is going to be equal to F1 times, what is the distance? Perpendicular distance is what? It's X times X. This will give me F1 X Newton what? Meters. Okay? That is the moment of F1 about A. That's the perpendicular distance that. So we are going to get moment of F2 about what? About A still. So this time around we shall have F2 times the perpendicular distance is what? Is what? B plus X. I think that B times D plus X. This will give me F2 D plus F2X. And this is Newton what? Meters. Is that okay? Yes. So we will have that resultant moment about A will be equal to adding the two. Adding the moment of F1 about A plus moment will be equal to moment of F1 about what? About A plus moment of what? Moment of F2 about what? About A still. So this is going to be, I'll have F1 X plus, it's going to be F2 D plus F1, F2 what? X. Is that okay? Resultant moment. You had the two of them. So now, but of course, we know that, what do we know? F1 is equal to negative of F what? F2. Or F2 is equal to negative of F1. You can write it like that. Or we can have it as F2 being equal to negative of F1. Doesn't affect anything. It doesn't matter. Okay? It is not a must that we have to say F1 is equal to negative of F2. Is that right? We can as well say F2 is equal to negative of F what? This negative can be on this side or it can be on the other side. Is that okay? It just shows that the two forces are equal, but then they are just opposite direction. But it doesn't matter where you put the negative. Okay? So let us come in. Where there is F1, okay? Let me use this. Where there is F1, I put negative F what? F2. F1 is equal to negative F2. Can we put that? So therefore, we shall have that. F1 would be negative F2. Now X. I think that this one now becomes negative F2X. We have replaced, instead of F1, we have put a negative of F2. Plus, this would be equal to plus what? Plus F2 D plus what? Plus F2X. I see that? You'll see that negative F2X plus F2X will do what? Will die out. I see that? So this becomes, the answer becomes F2D. Newton what? Meter. You can clearly see that if you are to get the moment of these couples, the moment of the couples is, it is F2 times D, the distance between the two forces, okay? Or, alternatively, we can have that, instead from here, we can say F2 is equal to negative of F1. Where there is F2, we are going to put negative F1. Are we together? Following this. Huh? So we can have that. We can have that F1 x plus. Okay. F2 is here, but F2 is negative F1 now. If we use this. So it will be negative F1 D, then plus, still this is F2, but F2 is equal to negative F1. To be negative F1 x. Is that okay? So you'll see that this one is what? F1x minus F1d. Is it that? Minus F1 what? X. Is that okay? So we will have that. This and this will cancel. F1x minus F1x will go. So remains negative F1. F1 what? D. I see that? This negative is just a direction. And which direction is that? Which direction is that? Clockwise. Let's see. F1 is in clockwise direction. F2 is giving us anti-clockwise direction as the answer in a. So the negative is simply showing us the opposite directions that they take. Okay? So you will clearly see that this is Newton meter. So you will clearly see that if you want to get the moment of couples, you just only take one of the forces. After all, the forces are what? They're the same. Then you multiply by the distance between what? Between them. I see that. So moment of couples is got by getting one of the forces and multiply by the distance between them. So if I want to get the moment of the couple of this, if this is 5 meters, then to get the moment of the couple of these forces, I'll have 50 times 5. Just pick this times 5. So it is one of the forces, just the force times 5. You don't say 50 plus 50 times this. No. You just pick this 50 times 5. That will give us the moment of the couple. Write and say, have we done it? Have we written up to here? Yes. You can write and say, therefore, the moment of couples about any axis. Therefore, the moment of couples, therefore the moment of couples about any axis, therefore the moment of couples about any axis is the product of one of the forces. Is the product of one of the forces and the perpendicular distance between them. Therefore, the moment of couples about any axis is the product of one of the forces. Is the product of one of the forces and the perpendicular distance between them. And the perpendicular distance between them. Very good. So, wow. That's that we completed. Friction was done, right? Friction was done, right? So you are still covering elasticity. So meaning, at least before this holiday program ends, we would have entered into simple harmonic. Simple harmonic motion, we have major 3 topics. Simple harmonic motion, gravitation, and then circular motion. Once we get done with those, the other one we shall just move at our pace and we get done with mechanics. So let's meet again. I think we shall have another lesson on a Friday night, I think. Yes, on a Friday night. That one we shall cover modern physics. But of course the other lessons, Irene is also going to be coming. She will come and continue with her part of elasticity. Then Ellie will also have one of the lessons to continue with his EAT. Okay? So let's meet in the next lesson. Thank you very much.